Today we're going to be talking about section 2.1, which is solving linear equations and inequalities. So your goal for today is to be able to solve both equations and inequalities. Before we get to all of the solving, we are going to take some time just to talk through what an equation is, what the solutions look like, what makes something linear, kind of all those little basic things before we get into the actual solving. So we'll go ahead and start right here with an equation. So an equation is a mathematical statement. And that statement tells us that two expressions are equivalent. And that word equivalent is really just a fancy word for equals, means they really are the same thing. So I have two equations that mean the exact same thing, okay? Or two expressions. Really what this boils down to is it's an expression that must have an equal sign between them. Has that equal sign, it's telling me those two sides of the equation are equal, and I can then usually solve for something there. As far as the solutions to an equation, the solutions are the value or values of the variable that make the equation actually true. So they're the numbers that I can plug in that give me correct statements for that equation. So it could be just a single value, or it could be multiple values of the variable. Or if I have more than one variable, they're the combinations of variables. Variable that make an equation true. So things that actually plug it in and make both sides of the equation equal to each other. Next thing we're going to talk about is our linear equations with one variable. We're going to stick to just one variable for now because as we're solving, we really can only solve for one variable at a time right now. We'll eventually get past that, but for now we're going to stick to one variable. Really, when we talk about linear equations, these are the simplest form of equations that we can have. So these are typically written in the form of ax is equal to b, with a couple things here where a and b are integers. Are integers, or are constants. They don't have to be integers, sorry. They could be fractions or decimals. So they're constants. And I also need a to not equal 0. If a were to equal 0, that would just cancel out this entire x, and then I don't have any variables. So I don't want that to happen. And I just want a and b to just be constants or numbers, just so they stay the same. If I start to change those around, then I'm really talking about more variables, and I don't have just one variable anymore. As far as examples of linear equations, something like 4x is equal to 8 is a linear equation. Something a little more complicated, 3x minus 2/3 x equals -9. Now this technically isn't of the form ax equals b yet, but I could combine like terms and I would be in that form. So it doesn't have to start that way. As long as I can get it to that form, that would be fine. Same thing, I could have x's on both sides, so something like 2x is equal to 0.1x plus 2. Those are all things where I could get those x's together on the same side, so I have ax equals b. As far as nonlinear things, anything with an exponent or a root is not going to be a function, or a linear function, linear equation. So 3 times the square root of x plus 1 is equal to 32 is not a linear function. Anything with an x in the denominator of a fraction is not a linear function. So 2 over x plus 1 is equal to 41. Or anything with x in a variable is not going to be a function. Or, sorry, anything with an x as an exponent is not going to be a linear function. Okay, so really all I can have is an x just multiplied by a number is equal to another number. That's all I'm really allowed to have. Now let's go ahead and get into some of this solving stuff. So to get into some of the solving here, there are actually steps to solving an equation. You have actually been solving equations for several years now though. So these steps I'm going to show you are really just if you're stuck. If you feel like you know what you're doing and you know what should come next, feel free to do that. But if you're stuck, you're not sure what to do next, these are the steps you can come back to. So the first step is going to be to simplify. And by simplify, I really am talking about each side of the equation. So you're simplifying each side. A couple things that could happen in that step, you might need to distribute. Sorry here. Make sure I spell this correctly. Distribute. We might also combine like terms. Are all things that simplify each side of the equation. Next step is going to be collect and combine. So collect and combine are kind of the same word, more or less. I'm really trying to get all of my variables together. So when I collect all my variables, or variable terms, to one side, I'm trying to get everything all to one side. Once I have my variables all combined together, then it's time to actually isolate that variable and find just what that variable is equal to. So that's where we're going to isolate the given variable. Okay, and just a quick note here again, we can only solve for one variable at a time. So if I have multiple variables, if variable is alone. Okay, so if I have any other variables with that, that's not going to work out for me. Okay, and just a quick note here, as far as how we do that isolation, we perform inverse operations. Perform inverse operations. To both sides in reverse order of operations. So I take my order of operations, which is really PEMDAS. Please excuse my dear Aunt Sally. And parentheses, exponents, multiplication, division, addition, and subtraction. And I do that in the reverse order. So I actually start with subtraction and addition. Those two again happen together. Division and multiplication again happens together. Exponents are my last thing. And then finally parentheses. So I actually kind of work in the reverse order of what I normally do. Okay, and again, these are steps in case you're stuck. If you know what you're doing, go ahead and solve. You know how to simplify equations at this point. All right, let's talk about example 1 here quickly, though. This is just a quick story problem. We're going to start with that, and then we'll get to some just regular equations. So I have Alex is paying $19.99 for cable service each month. He also pays $2.50 for each movie he orders through the cable company's pay-per-view service. If he was billed last month $32.9, how many movies did Alex order? So what I'm looking at here is I have three numbers. There are $3 amounts that I'm going to be working with. I am trying to find how many movies Alex has ordered. That is going to be my x. So I'm looking, I have a total here. So I'm going to set my equation equal to that, my $32.49. And I know that total is made up of two things, the amount for the cable service as well as the additional cost for each movie. So I'm going to cable service, that's my $19.99. I'm going to add to that my cost per movie, which is $2.50, times the number of movies I have, which is x. I can then go ahead and solve that. So I'm going to subtract my $19.99 from both sides, which gives me 250 is equal, or 250x is equal to 1250. I can then divide by 250 on both sides, getting that x by itself, and x here will equal 5. So what that tells me is that Alex paid for 5 movies in that given month. Okay, so quick story problem, get your equation set up. Then it's just a matter of isolating this variable. This one I did not have to combine or simplify it on the sides either. I just had to get this x by itself, so I moved the 19. That's furthest away from the x, that's the adding and subtracting. Then I do my multiplication and division and divide by the 2.5. Okay, go ahead and flip over to the back side of this page now. And we'll talk about example 2. Example 2 are really just some more of our solving ones. So I just need to simplify here and get my left-hand side simplified. So I'm going to go ahead and distribute the 2 to both pieces, which gives me 6x minus 2 is equal to 34. Then I can go ahead and solve that. I'm going to add 2 to both sides, which gives me 6x is equal to 36. I can then divide by 6 on both sides, and I get my final answer here of x is equal to 6. Now, that is technically what the steps tell us to do, but I do want to show you there is a little trick here. When you are distributing, if you are distributing and that's the only thing on one side of the equation and the other side is simply a number, you can actually get rid of this 2 to begin with. So instead of taking and distributing the 2, I'm going to do this a second way. I'm going to just divide by the 2 right away because that's just being multiplied. I can undo the multiplication by dividing, so I'm going to divide by 2 on both sides. When I do that, I then have 3x minus 1 is equal to 17. And I can continue to solve from there. So I'm going to add 1, gives me 3x is equal to 18. And if I divide by 3 on both sides, 18 divided by 3 again gives me my same answer of 6. So 2 different ways to do the same problem. Either one is fine. It is completely up to you which one you are more comfortable with.